Hello and welcome. I'm Dow Thornton with Garmin International, and today's webinar is going to be on choosing the correct transducer. So as always, if you have any questions, please feel free to send an email to marine.training@garmin.com, and we'll get back to you in a timely manner. So first thing I want to go over is our transducer selection guide. If you go to garmin.com, you can type in transducer selection guide, and it should pop up. If not, if you type in what MFD you have, go down to the bottom tab. You should see an option for accessories. If you click on that, transducer should pop up. And once you hit select transducer, it should go to the transducer selection guide. A couple things you guys are going to need to know before you get here is, what type of transducer are you looking for? In-hole, through-hole, transom mount. How do you use your boat? Do you fish? Do you sail? Do you just cruise? If you do fish, do you saltwater fish? Do you freshwater fish? If you saltwater fish, do you do inland fishing, offshore fishing? If you offshore fish, do you do, deep dropping, sword fishing? So these are things we need to know to select the right transducer. What is your boat made out of? Is it fiberglass? Is it a cord hole boat? So do your homework, guys. Know your dead rise of your boat if you're looking at a through hull. That's something these are all things we'll go over in this webinar. So again, the transducer selection guide, it's a great tool. There's hundreds of transducers that'll work on our units. So I can't go over all of them. So make sure you do your homework. But this tool is going to give you a lot of information about the frequency ranges of transducers. It's going to give you water depths, and this is huge because transducers won't read as deep in saltwater as they do freshwater. So know this going in. I usually take 20 to 30% off the depth range when I know that, hey, I'm fishing in salt water. The other thing you guys need to know is know your MFD. If you look at the back of a Garmin MFD, you're going to see a blue port or an orange port. The blue port's going to tell you that takes an 8-pin sonar. And this is going to tell you in that transducer selection guide, it'll tell you, hey, I'm looking at a GT52 transducer, orange connector. That means it'll plug into the orange port on the back of the unit. It will not plug into a unit that only has a blue port. So the blue port is going to tell me that unit only has traditional sonar and clear view. It will not do side view. Okay. If you jump up to a unit that has an orange pin port on the back, that's going to tell you that unit will do everything. It'll do side view, down view, or clear view, as well as traditional sonar. And if you jump up to like the new 8600 series, it's going to have a blue and an orange port on the back. And what that should tell you is that's a dual chirping unit. So you can plug multiple transducers in, and we're going to go over a few options a little later. But that's what we mean when we say dual chirp. There's 2 ports on the back. You can plug 2 chirping transducers into it. We also have a yellow port on the back of the 8600s, and you'll also see those on the new EchoMap Ultras. That is for a new LVS 12 LiveScope, which I'll go over as well. So let's go over some basic knowledge on transducers. So if we look up here on the top left, dual frequency transducers have been out forever. You've got that cone that goes down up under the boat. Usually frequencies are either a 50-200 or a 77-200. So those transducers only have 2 frequencies. In the middle, when we look at CHIRP, CHIRP is very popular now. Everybody wants chirping transducers. That's scanning multiple frequencies. So if I have the ability with a CHIRP transducer to schedule to chirp 40 or 50 different frequencies. If I have a dual chirping unit, I could almost chirp over 100 frequencies. Again, it's in that cone angle, multiple frequencies going into water. The more frequencies going into water, the better the target separation, the more returns you're going to get back on that screen. When you're looking at clear view and side view, the transducers or the frequencies that go out in those are a little different. Instead of that cone, you're basically getting a very thin line, a very thin pulse. So think of like a page in a book. Every pulse is a page in the book. And the nice thing about that, when you get all those returns put together, you get a great image of what's on the bottom. So if you're looking for a wreck down there, maybe it's a sailboat, you're going to get a nice outline of the sailboat, the mast. I mean, it's going to be perfect. You're not going to get that back on a traditional chirping transducer with that cone's too wide. So you're not going to get that crisp picture back like you get in a clear view and a side view transducer. And of course, we have our phased array sonar, our Panoptix that came out about 4 or 5 years ago. It's going to give you that great 3D picture on the bottom. You can actually watch your drop shot going down. You can see fish swimming around. Pretty phenomenal. And then, of course, we have the famous LiveScope, which is basically your ultrasound of targets out there. So again, this was designed for freshwater. It's a high frequency transducer, pulsing out between 500 and 1100 frequencies all every second. So that's how you're getting this image back to the boat. So let's talk about a little CHIRP 101. So transducer frequencies, they are available in 3 basic ranges: a low, medium, and high. Low CHIRP frequencies range from 40 up to about 75 kilohertz. That means you're pulsing all those frequencies at the same time. Medium CHIRP are 80 to 160 kilohertz, and then your high CHIRP frequencies are 150 to 240 kilohertz. Remember, guys, you cannot run 2 of the same frequencies at the same time. So you can't run 2 medium band chirping transducers at the same time. And I say this because I get a lot of calls about, hey, I'm running a medium band transom mount transducer on the back of the boat, and I have a bronze through-hull in-hull, and they're both medium frequencies. What happens, you're going to get crosstalk. So you can run a medium band transom mount and a low or a high through-hull, but you can't have 2 mediums. You can't have 2 highs running at the same time. Low frequencies are designed for deep water. They give you a wider beam angle, so it covers a lot of area. It'll penetrate, if you're trying to read over 1,000 feet. High frequencies give you a narrower beam, so shallower water, they're excellent. And you also have your medium band frequencies, which are really the best of both worlds. One thing, shallow water, I definitely recommend using a higher frequency if you're in, less than 100 feet, if that's your normal fishing. Especially if you're shallow fishing, 20 feet or less. A lot of times I'll get calls about, hey, my unit's just flashing 000. Usually what that tells me is you're running a low frequency transducer, and you've got that 50 and 60 kilohertz trying to pulse. That pulse is trying to get to over 1,000 feet of water. And when you're in shallow water, that frequency hits the bottom and bounces back so fast the unit can't pick it up. So thus the unit will just flash. So when you're in shallow water, go to your higher frequencies, okay? Get up into your 200 range. That pulse rate's a little slower, so when it hits the bottom in 5 feet of water, 10 feet of water, it bounces back and the chart plotter can actually read it. Also, certain fish are more detectable at specific frequencies. So again, in the Garmin chart plotter, if you're running a CHIRP transducer, you can actually go in there and select what frequency you want to read. So if you're running a mid-band CHIRP 80 to 160 and yellowfin tuna show up best between 85 and 90 kilohertz, you can actually go in there and preset 80, 85, 90. So it'll ping just that one pulse rate out, or that one frequency going to the water. So the units are capable of doing that as well. So a couple options for mounting. You have your transom mount options. That's probably one of the most popular, especially on the inland market. Again, make sure when you're selecting a transducer what your chart plotter is capable of reading. Transducer placement. The key with mounting any transducer on the boat, but especially a transom mount transducer, it's got to be hanging just below the bottom of the boat, or the bottom end of that transducer just below the boat. You need good, clean water coming off the hull of the boat going over that transducer. You can't have any disturbance. You don't want it tilted up. You don't want it tilted down. A lot of times I'll go to a boat and this transducer will be about another, 3 or 4 inches up. And when water comes off this hull, it'll swirl right here. That causes disturbance. You're going to hear me repeat this a few times. Clean water. You have to have clean water going over a transducer. So look up ahead of where that transducer is going to be mounted. Is there a chime? Is there a high-speed pickup? Is there anything that's going to cause disturbance? A lot of times I'll get a call about, hey, this transducer is reading great at, when I'm at doing 5-10 miles an hour. When I get up on plane, I lose the bottom on the screen. That's because you've got dirty water. Just think, guys, you've got a lot of stuff on the back of that boat: props, trim tabs. You've got chimes on the hull of the boat, high-speed pickup. So all of that can cause disturbance. Also, if you have an issue with rooster tail, big spray coming out those all-in-one transducers, we do make a spray shield. I think it's around $20. You can mount on your transducer, and that'll knock that spray shield down. Don't mount your transducer like this. Okay, it's not going to work. This could be mounted up or down, but it was mounted right in place of a chime. So this transducer is never going to read correctly. Again, chimes will cause this. If you've got a high-speed pickup or a discharge or anything up in front of that transducer, it will cause interference. Another type of transducer very popular right now is the tilted element through-hulls. So these usually come in a 0, 12, and 20-degree tilt. So you've got a nice clean installation with a tilted element transducer. You do need to know the dead rise of the boat. So, if you've got a go fast, a deep V boat, you're probably going to have to go with a 20-degree tilt. These you can go plus or minus about 5 degrees. So let's say you've got a boat that has about a 16 or 7-degree tilt. You can either go with the 12 or the 20. I'd probably recommend the 12. But again, if you're going with a 12-degree tilted element, you've got a plus or minus about 5 degrees on that. So this is something you definitely probably need to talk to the manufacturer and know your dead rise if you're looking for a transducer. The other option is your transducer traditional through-hull with fairing block. This is very popular. There's certain times where you're going to have the fairing block versus going with a traditional through-hull or a through-hull transducer. But these are very popular. You can get them in different frequencies, low, medium, or high. You can also get them in a high wide or a low high together as well. Again, transducer placement is key. Look at the boat. They need to be in front of those engines. Good clean water coming off the bottom of the boat needs to cover them. If you've got a stepped hull boat, it's got to be in front of that first step, and I'll go over that in a minute. You need to be in front of the keel if it's on a sailboat. So you need to do your homework when you're selecting a transducer. We also have in-hull and pocket mount transducers. So a couple of different options for you. A lot of the big offshore cruisers use the in-hull or the pocket mount. So if you're mounting this type of transducer, make sure you test the area before you glue it down. I usually recommend fill your sump up with water, put that transducer in there. And again, the boat needs to be in the water for this to work. Put that transducer in that sump, fill it up with water, move it around so you mount it over a stringer. If you're, you can also put it in a Ziploc bag, fill that bag full of water, move it around, make sure you got a good location. When you go to glue it down, you can use, a slow curing epoxy to glue it down. If you get one that if you have a transducer that you need to put fluid in, mineral oil or antifreeze will work. We were talking about why sometimes it's best to go with a fairing block versus a tilted element transducer. So on boats usually over 35 feet, there is a boundary layer on the hull of the boat. And that's basically a thin line of water, air disturbance water, or bubbles, or whatever you want to call it. But that will create disturbance over a transducer. And if you have a tilted element mushroom style transducer to the bottom of the boat, you're not going to get through that boundary layer. So you need that fairing block, which is going to push that transducer through that boundary layer. So, I get a lot of calls about where do I mount this transducer? And, every boat's different. Boats, barely moving and boats up on plane, the hull of the boats do look completely different. So with this scenario, you can see on this boat, we've got the chimes, we've got a lot of water disturbance, a lot of disturbance up under this boat. So you wouldn't want to mount any transducers out here. Best location would be somewhere about here for a through-hull transducer. In this scenario, twin screws, a lot of disturbance on this boat from the chimes. When this boat's running, it's doing completely different things in the water than when you're barely moving. So transom mount transducer wouldn't work. You would need to mount that transducer somewhere near the keel of the boat. Okay. Stepped hull boats. I get a lot of questions about this at boat shows. Hey, I got a stepped hull boat. I'm going to put a transom mount transducer on it. Don't do it. It's not going to work. A lot of disturbance comes off a stepped hull boat. So where would I mount it? You have to mount your through hulls or your pocket mount transducer style in front of that first step. Okay, that's the only place you've got good clean water when you're running that transducer is going to work. Also remember, guys, wide cones. High frequencies usually produce low frequencies, the 50, 60, 70 frequency range produce wide cone angles. So the deeper you go, the wider that cone angle is, the more area you're covering. But if you're in 50 feet, if you're in 50 feet of water, you're looking at a 22-foot span across the bottom. But if you're in 1,000 feet, you're looking at 443 feet spread across the bottom if you're in a 25-degree beam. So again, pick your transducer. When you see a target on the screen, if you're in 1,000 feet of water, if you see that target on the screen, it's somewhere in that beam 443 feet around you. So a couple of things you can do on your chart plotter, but I want to make sure you guys know how the transducer works. When that traditional transducer is shooting that pulse down, it's shooting that cone down. Like I said before, the deeper you go, the wider that cone. When you see that target first appear in that cone, you see the beginning of that arch or chevron. The highest point of that arch or chevron, he's in the center line of that cone. And when you see the tail end of that arch or chevron, he's gone through the cone. So again, when you're looking at the screen, when you see that fish on the screen, on the far right of your screen, when it first appears, it's already gone through the cone. So if you're in 1,000 feet of water and you're looking at a 400-foot span across the bottom, when you see that fish on the screen, it's behind you. Everything you see on side view, down view, traditional sonar, that fish has already gone through the cone. So just remember that. But if you have a Garmin chart plotter, you can actually go into your menu on your traditional sonar and turn on your A scope. And what A scope does, it's going to show you this. You're going to get about an inch extra screen on the right-hand side. And what happens here, this is going to show you that center line of that transducer. So remember when I said that center line of that transducer is the highest part of that chevron or arch, that fish is directly up under that transducer. So when you see that fish or chevron here, you are sitting directly on top of it. When you see it on the screen here, you've already gone through the cone. So that fish is somewhere outside of that cone. So when you see fish, structure, anything appear in A scope right here on the far right of the screen, you are directly on top of that structure. Okay. Also, a nice thing to know, this number right here, this number is going to tell you how wide that cone angle is. So again, if you're in, 360 feet of water, I'm looking at over a 200-foot cone angle around the boat. But I know when I see that target in this area right here, I am directly on top of it. Okay, so turn your A scope on. Right there. So let's talk about interference real quick. So there's two types of interference I see on the boats. The first one, when I see these vertical lines right here spaced out, that usually tells me it's a electrical interference. So check your transducer cable. Make sure it's not anywhere where there's power cables laying next to them. You need to get that separated. So you may need to pull that transducer cable out, put it on the other side of the boat, get it away from any electrical wires. On the bottom right here, normally this type of screen tells me that you've got dirty water, you've got air, bubbles, something's going over that transducer, usually causes the screen to look like that. So if you got vertical lines spaced out, it's usually a sign of electrical interference. If the screen's kind of full, kind of blurry, like on the bottom right, that should tell you that you've got something in front of that transducer that's causing disturbance. So let's look at some different transducers. So first ones we're going to look at real quick are the freshwater configurations. So normal bass boat, we're going to probably be running a LiveScope up front, and then either a GT54 or a GT52 up front on the trolling motor. If you have a forced trolling motor, it comes with a GT54 UHD built in. Then on the back of the boat, normally your options are going to be probably a GT8, which is going to be glued in the boat, and then a GT34 or GT30 on the back of the boat for side view and down view. So in this scenario, we've got our GT8 traditional. That would be our running transducer. Then when we're fishing, we could still run this transducer for traditional sonar. And then we have our GT34 or 30. These are side view and clear view only. No traditional sonar in these transducers, so they work together. And then up front, we're going to be running our GT54 or 52, which is going to be our all-in-one side view, down view traditional transducer. When you go with this option, you're probably going to have to add the Y cable. So if you have a EchoMAP unit, an EchoMAP Ultra unit, or a 1242, 1042, if you only have that single orange pin port on the back to run these two transducers, the orange pin port would plug into the back of the unit, and then your GT8 would plug into the blue port, and then your GT30 or 34 would plug into the other orange pin port. So again, traditional, side view, and down view built into these two, okay? So best options right here, if you've got a 12-pin connector on the back and you want an all-in-one transducer, the better would be the GT52. It's a high-wide chirping transducer, 250 watts. So you're chirping at 150 to 240 kilohertz, wide angle, and it's 455, 800 on side view and down view. The best option, if you're just want an all-in-one, just one transducer on the back of the boat, the best option, if you have a unit that would read the GT54 UHD, so that's the EchoMAP UHD units, the EchoMAP Ultras, and then the 8600 series. This is a 350 watt unit, so you've got a little more power. It's running the 150 to 240 kilohertz as well, but you have that UHD, that 1.2 megahertz on side view. So that's going to give you that great picture. If you want, if you're a bass fisherman or a flats fisherman, you really need to look out to the side. You need great detail. You want to step up to the UHD. But just make sure your unit's capable of running a UHD transducer. If you plug this transducer into a unit that's not a UHD, you're not going to run those high frequencies. You're basically going to run the same frequencies in the GT52. But these are two great transducers, the GT52 and the GT54. Again, looking at the GT54, 800-foot depth, 200-foot side to side. I would cut that down if you're in salt water. You're looking at about 125 feet on each side of the boat, and that 200 feet would be for a clear view. Again, I would cut that down if you're in salt water, okay? But again, great transducer. I actually use this transducer. I use the GT54 and I saltwater flats fish, and I get great picture imaging back when I'm looking for structure on the bottom in shallow water. The GT34 and the GT30. So that first slide I showed you showing the bass boat and the configuration, that's how we're rigging the majority of our pro staff this year. They're running the GT8 in-haul with a GT34 and 30 on the back. So the GT34 is good for shallow water. Normally we say, 30 foot or less. If you're fishing over 30 feet of water, we recommend going with the GT30. Again, these depths will vary. They're both great transducers, but they only have side view and clear view built into them. So if you want a traditional sonar, you would have to go with that in-haul. And the reason we do this, we wouldn't want a GT54 on the back and a the GT8 in-haul, because we don't want to run those two chirping frequencies at the same time. So this way we're running the GT8 in-haul with our traditional sonar, and we're going to have side view and clear view on the back, which is our fishing transducer. So we really don't need to see these two transducers until we come down off plane and want to start fishing. That's where we would take advantage of our side view and clear view. With our in-hauls selection, we have the GT8 high-wide in-haul, and we have our GT50, which is a medium chirping in-haul. So again, these two transducers are in-haul options, so they're going to have the blue connector. The GT8 comes with this foam ring, so you basically peel off the 3M tape this down where you want to mount it. You fill this ring up with epoxy, and you can set the transducer inside that ring. With the GT15, you actually mount one of these rings, depending on what the dead rise of your boat is. You fill it up with mineral oil or antifreeze, and then you connect the transducer. You would bolt the transducer into the ring. This transducer would float inside the ring here filled with your fluid. But these are your two options. They are chirping transducers. So most of the bass boats out there are going with the GT8 high-wide in-haul. We also just want to make sure you guys know we do make a kit available. So if you want to go with a GT30 and a GT15, or a GT30 and a GT8, this is available. You would have to add that Y cable, as we spoke before, if you're not running a GPS-MAP series that has an orange and a blue pin port. You would have to run the Y cable. So looking at the saltwater configuration, a lot of saltwater boats are running with maybe a transom mount transducer. A GT51 medium would be a great choice. Thru-Hull option, we'll talk about some Thru-Hull options here. Again, the one thing you couldn't run with this combo is the medium band frequency. Since we're running the medium here, you would want the low or the L high in a Thru-Hull. Or if you want to step up to the GSD26, our black box, then you could pick several different transducers. When you jump up to the GSD26, this box will read up to 3,000 watt transducer, so you can select the right transducer for this box. This is really for deep water. So kind of a better and the best option here. You could go with the GT50 medium band CHIRP transom mount, or the GT51. The GT51 probably be, if you're offshore fishing, would be my choice. Again, it's a 600 watt transducer versus a 300 watt. So a 600 watt transducer, more power means it's going to read in deeper water. So you're going to get a little more penetration in salt water. So again, both great transducers. If you're more of an inland guy, the GT50 would work. But if you're offshore and deeper water, definitely go with the GT51 medium band CHIRP. These two both, again, since they're an all-in-one 12-pin, they also do side view and clear view as well. When we're looking at saltwater Thru-Hulls, so good. Let's talk about the B60. The B60, it's a 600 watt transducer, but it's only dual frequency, so it only shoots 5,200. This is a great choice if you're not a serious fisherman, if you like to cruise around. You can still penetrate the water column very well, get a great return. If you are looking at a chirping transducer, your first step up would be a B150M. That's a medium band chirping transducer. Again, that's 300 watts, so you're going to lose some power. Again, it's a chirping transducer, but with 300 watts, you're not going to penetrate. So although the B60 is is only a dual frequency, it is 600 watts, so it will read a little deeper. Way better would be the B75. You could go with the M or the H. That is a chirping transducer, 600 watts. The next step up, probably one of the most popular transducers out there for the offshore guys is the B175. Again, this is going from a 600 watt to a 1,000 watt transducer. Again, remember guys, when you go up to a 1,000 watt transducer, it's a pretty big hole you got to cut in the bottom of the boat. You're looking at, in the B75, maybe a 2.5 inch hole in the bottom of the boat. You're about a 4.5 inch hole in the bottom of the boat, if not a little bigger when you're going up to a 1,000 watt transducer. So these are available in low, medium, high, and a high wide transducer. And again, most of the offshore boats, 35 feet and under, this is the choice they go with. And then again, the best would be also a B265. This is an LH, so it has the low and high frequency built in. 1,000 watts, so it is a 12-pin orange connector. Comes with the fairing block. So again, how we talked about that boundary layer earlier, if you need to go get through that boundary layer, maybe your best choice would be the B265 LH. If you're looking at an all-in-one scanning transducer from Garmin, we make all these transducers. All the other transducers we were talking about were the bronze Thru-Hulls, are made by Airmar. We use all Airmar transducers. Any transducer that is an all-in-one scanning transducer, if it's a side view or clear view transducer, we make it. Whether it's Transom mount or Thru-Hull, we make it if it has side view and clear view built into it. So your options here would be 8-pin GT23M. That's a medium band chirping Thru-Hull. This will give you traditional and clear view. You will not get side view. If you want side view, you can jump up to the GT51M TH or the GT51M THP. The THP stands for Thru-Hull pair. This is going to come with 2 transducers, one for port and one for starboard. Okay, so if you go with the GT51M TH, it's a single transducer. The THP is going to come with a pair. Again, these are traditional medium band chirp, side view, and clear view. So if you're going this route, you need to know your dead rise of your boat. Okay, the reason being is that anything over 5 degrees, you have to go with a pair of transducers. So if you've got a dead rise of 0 to 5, you can get away with a single transducer. Okay, if your dead rise is over 5 degrees, you have to go with a pair, because this transducer cannot read through the hull. So you would want one on port and starboard. That's the reason why you would step up to the Thru-Hull pair. Black box system. So a lot of customers like to just add one of the black boxes to their MFD. So if you have a 742-942 XS and you want to add side view, remember that unit only has a blue port on it, so it will not do side view. So you can add the GCV20 scanning sonar black box. So that will plug into the network port on the back of the unit. Your GT30 transducer will plug into the GCV20. So you probably will have to remove whatever transducer you have on the back of the boat and add the GT30. If you jump up to let's go to the bottom, GSD25. This is basically the box that's built into our GPS-MAP series XSV units. So if you already have a unit that's an XSV, it has a GSD25 built in. If you don't have an XSV unit, you can add the GSD25 and it's going to give you all those features. So this box is capable of dual chirp. So you're going to see an orange port and a blue port. So we could plug in a transom mount transducer as well as a Thru-Hull into this box. And we'll go over a couple of scenarios in a minute. And then our bad boy out there is our GSD26. This will handle up to 3,000 watts, so you can put up to a 3K transducer into it. So again, I would definitely consult with your boat builder or a dealer, or contact Garmin and making sure we're getting you the right transducer for the GSD26. This is a hardwired box, so These transducers have bare wires, so you do have to hardwire it into this box. And one quick note, make sure you put that cover on that box after you hardwire it. If the cover's not on, the box will not work. Just an FYI, I get a lot of calls about that. So let's look at a couple examples of dual chirp. So as I mentioned before, our units are capable, or the 8600s are capable of dual chirp. You've got the orange connector and the blue connector on the back. To make a unit dual chirp, those transducers must be plugged into a single unit. If you have multiple units hooked up, you cannot have one transducer plugged into one unit and one transducer plugged in the other unit. They will work. You can share transducers with both screens, but if you want to make a combo with dual chirp on one screen, those transducers must be plugged into one unit. So a couple scenarios here. We've got a GT51M plugged in, so that's plugging into our orange pin port. So we're using the medium band frequency, side view, down view. And then on the blue pin port, we've got the B75L. Thus, we have dual chirp. We have the low, we have the medium, we have everything built in right here. That would be on an XSV unit. If you have a non-XSV unit, you could plug a GSD25 into a non-XSV unit, and then again we can connect this configuration in here, or we can put a B75M into the blue connector or the orange connector, and then we could get there's an adapter cable available to go from orange to blue, and then we could plug the B75L into the other. So now with the adapter cable, we could plug the M into one port, L into one port, and we have dual chirp. Okay, that's a very popular configuration. Here's a scenario where we have multiple units hooked up. So we have a B75L plugged into the 8-pin port, the B75H plugged into the 12-pin port with the adapter cable, and then we have a GT51M plugged into the other unit. They're networked together so we can share all the 3 transducers across all 3 screens. But if we want to make a combo screen with dual frequency, we can only see that in this screen right here because both transducers are plugged into this unit. Okay, again, we can still share side view and clear view to this unit, but we can't do dual chirp. So we can't do one screen with a B75H and the M frequency. We can only do the L and the H frequency in a split frequency screen. This scenario, we're showing, again, 2 screens connected with the network cable. We're running a B75M medium frequency in the blue pin port, and then we've gone up to the B265LH into the orange pin port. So now we're running the medium frequency, the low frequency, and the high frequency. So we've got basically everything covered here. So everything is shared into this screen. We can run dual frequency, and we can share everything over to this screen. Last but not least, well, maybe not last but not least, this is a scenario where we have a GSD26 networked, so we're sharing that with both units. We've got a R509LH, so this customer is probably fishing deep water because he's probably sword fishing, deep dropping, so he needs that GSD26 to get to those depths. And then he's running the GT51M on the transom mount for a side view and down view when he's fishing shallower water. So this will work perfectly. So real quick, let's talk about Panoptix and Panoptix LiveScope. So Panoptix, the original Panoptix came out about 5 years ago. So there's a couple of transducers available out there, and these are the 2 I would recommend for the saltwater guys. Now, if you go with the PS30 or the PS60, the PS30 is a transom mount, the PS60 is a through-hull. Really, these are not running transducers. These are fishing transducers. So when you need additional transducers on the boat when you're fishing, when you're running, when you come off plane, you're looking for that structure, you're looking for those fish, that's when you would use these 2 transducers. So they're going to give you the live down, so you can actually watch your jigs going down. You can see fish swimming around. That's on the PS30 as well as the PS60. You're also going to get the 3D down on both units, as well as the 3D historical. I don't use the historical too much because, again, it's history. I don't really care what's already behind me. Unless it's structure I went over, then I want to go back to it and I can mark a waypoint. I would want to use the 3D here, or the live down. The live down's probably my most popular. I like to go up to, if I'm grouper fishing, I can go over a wreck, I can see amberjack, I can see fish swimming around, I can actually watch my jig go down. I actually see the strike as it happens. So I know exactly if there's fish down there or if there's no fish down there. So these are two options. One thing I do want to note on the PS60 Thru-Hull, the actual transducer is right in the middle. So that's a fairing block, and it's a little overwhelming, this fairing block. So it's the size of a football. You don't have to use this fairing block. It's a pretty long stainless steel stem. So if you have an area where you can recess this transducer right here into the hull of the boat, you can get away with the fairing block, okay? So don't let it scare you. We also make the PS51. So this is more of a collision avoidance transducer. So it's a stainless steel through-hull. It's, again, the transducer does stick out below the boat a couple inches. So if you do have a trailered boat, you do want to be able to, you do want to pull that stem out before you run it up on the trailer. It does come with a blanking plug so you can put into it. We've sheared these off during testing, hit logs. If you cut that off, no water is going to penetrate the hull of the boat. You would need to pull that out, put the blanking plug in there, and you would have to replace the transducer. The element is actually in the very front of the transducer right here. It actually has the range of up to 300 feet in front of the boat. It's a 20-degree cone angle. So the nice thing about a 20-degree cone angle, if you're trying to come into an area, and again, this is a collision avoidance. It's good for slow speeds. It's not going to help you when you're doing 80 miles an hour and you're coming to an entrance to the harbor. Slow speeds, you're looking for a channel, 20-degree cone, so you can find that channel. You also get the fishing live forward. So again, you can see the bank going up, you can see targets in front of you, you can actually watch your lure going through the water as well. So a quick video I'll show you. Again, we're cruising, trying to get up under this bridge. Which piling do we need to go through? We can see on our front view, we have at 300 feet, we're going to run aground. You can actually go in and set an alarm. So a red line will come up if I set this for 5 feet, and it'll tell me, hey, once that alarm turns on, it'll tell me, okay, I'm going to run aground in 150 feet. So I need to turn the boat until I have good clean water. Right there, there's my pass through 375 feet. I can go up on speed. Again, turn the boat. Now I'm going to run aground in 100 feet. I need to turn the boat back, find the channel, find that entrance in, bam, I can go through. So, great choice for collision avoidance. This is not a running transducer. This is really a transducer for collision avoidance. It's a lot cheaper than replacing motors, props, or a hole in the bottom of the boat. Let's talk about Panoptix LiveScope. This came out a couple of years ago, about 2 years ago now. This is the Mac Daddy. The LVS32 is the black box with the transducer. So this is the next step up from Panoptix. So again, this was designed for the freshwater guys, the bass guys. You can use it in salt water, but the frequencies are very high. You're pulsing up to 1100 kilohertz. So again, with that high frequency, you don't get range. So for me, I tell people this is basically 100-foot range in front of the boat and down. So casting distance. So for me, I want to see that target in front of the boat. I want to see my lure in the water, and I want to watch my lure, how I present it to those fish. So again, casting distance. But if you've never seen it, there's nothing like Panoptix on the water. So we do make a through-hull version of this. So the saltwater boats, the bigger boats, stainless steel through-hull, comes with the black box. But again, it's limited range. So you're not going to read 300-400 feet out with Panoptix LiveScope. You're better off going with the Panoptix, the PS51 or the PS30 or 60. So the beam angle on LiveScope is a 20-degree beam, and that's great for freshwater fishing. So if we look at, let's say we have fish in front of the boat about 60 feet out, we're looking at a 22-foot span across in front of us. So chances are, 60 foot out, I see those 3 fish on LiveScope, I can make that cast And I'm going to be in that strike zone of those fish. So, you know, our competition trying to copy us, their unit is doing a 40-degree cone. 40-degree cone is a little wide. So at the same 60 feet, we're looking at a 60-foot cone out in front of us. So, you know, those fish could be anywhere. So I may make a cast and I'm nowhere near those fish. So you definitely want a narrow cone when it comes to LiveScope. And again, the max range is 200 feet forward and 200 feet down. Again, in the perfect world, you're really at about 100 feet forward and 100 feet down for LiveScope. Because again, those frequency ranges, 530 through 1100, those are pulsing those frequencies all at the same time. So that's how you get that great, you know, that ultrasound image back, but the range is limited. So we did just come out with the new perspective LiveScope mount. This is very popular. So it's a $99 mount that mounts to your trolling motor. You take your LiveScope, your LVS32 LiveScope transducer will mount on the new LiveScope perspective mount. And these are shipping now. So that's going to give you basically, you're still going to get that front view and a down view on LiveScope, but once you turn the perspective mount down, you're going to basically get that view, kind of like, let's say you're at a baseball game and you're behind home plate about 10 rows up looking out at the field. So instead of that 20-degree cone out in front of you, you've got a 150-degree cone. So now you're looking at the whole baseball field. So I can tell if there's fish in left field or right field. Pretty amazing. This is a game changer. So you've got almost a 150-degree view in front of the boat. So I can turn that transducer, see fish swimming around. I can see structure that I may miss. So that's the new perspective mount, and it is available. So again, you buy the perspective mount for $99. You mount it on your trolling motor. And then that LiveScope will still give you your live forward in this view, your live down once you change your orientation, one click down, and then the mount actually swings down to give you your perspective view. So now you have all three views. You still keep your same LiveScope, no additional transducer is needed, and just by adding that $99 perspective mode, you still have the availability of to do forward and down, and we just add perspective. So real quick, last but not least, I want to talk about the LVS12. So I talked about the EchoMap Ultras, the new yellow pin port on the Ultras and the 8600s, 10, 12, and 16. That's for the new LVS12. So this is an inexpensive LiveScope. It's only $499, but it is limited, okay? This only gives you a 30-degree forward and a 30-degree down beam. So you're going to lose those fish when you're changing mode. So if you do have your chart plotter on dual screens and you made a combo, you will lose those fish. To me, this is a little more grainier of a picture. So again, it's $499. It is, if you guys that have seen all the great videos of LiveScope out there, they're using the LVS32, but this is an entry-level LiveScope. So make sure you do your homework and you get what you pay. You can definitely get what you pay for. But again, it's a great system. But if you're used to seeing or fishing with the LVS32 LiveScope, you may be disappointed in the LVS12. Again, the LVS12, you have a 30-degree forward and a 30-degree down, so you do lose the bottom, where on the LVS32, you get the full 135, you get the live forward, the live down, and you can use the perspective mount, okay? That's it, guys. Thank you for staying around and listening to the webinar tonight. Again, if you have any questions, please drop us an email at marine.training@garmin.com, and we'll answer them as quick as we can. Thank you, and get on the water, guys.